Hi, my name is Steve. I'm a clinical representative with Boston Scientific. I've been doing this for about 6 years now. I normally support troubleshoots and implants throughout London and the South East, but today I'm going to take you through the 3300 PSA and programmer. Now we've powered on our programmer, and the first thing that we need to do is interrogate the device that will be implanted. So take your telemetry wand, place it over the device and then press quick start. As you can see, the telemetry wand can now be removed. Remember, it's important to start the device application before the PSA so that you can communicate and transfer the implant measurements from the PSA to the device. Once you've interrogated, as usual, the summary box will pop up. So once we close the summary screen, we're taken to our familiar device programming screen. I'd always recommend programming the device as early as possible in the procedure so that as soon as you need it, you know that it's safe and ready to go. So work your way through as normal, and when you're ready to change the PSA application, press this button in the top right corner. This is the PSA screen. You can see we've got our PSA RV signal here, and the current sensing is displayed in millivolts under each beat detected. Our pacing controls are down in the bottom left, so when we start, we'll pace at 95 beats a minute with an output of 5 at 0.5. So if we press here, we come on pacing, we can see our change in morphology, and we now have an output voltage displayed with each pace beat. The R wave and the impedance are automatically saved, so you don't need to worry about recording them anywhere. Going into the magnifying glass on the RV column, this takes you to the threshold testing page. We're currently pacing at 5 volts, and as we decrement down, this value changes here and is updated on the EGM as well. So we gradually decrement down and find our threshold. There we go. So we'll come back up to find a stable threshold. There we are at 0.7. You can save this as your threshold, and it's now recorded over here. As I said, it would automatically record your impedance and sensing at the same time. As you save the threshold value, it automatically increases the output back to 5 volts to make sure you've got adequate safety margin for pacing. To test for phrenic nerve stimulation, press and hold this button, and that delivers 10 volts at 2 milliseconds. We can now come back out of here and then wean our patient down and turn off pacing. If you need to adjust any of the other pacing settings, the menu in the bottom left hand corner here gives you options for the starting voltages, pulse width, and also the sensitivity. There's also a line filter option, so if there's noise you can turn a 50 Hz filter on, but nominally it's turned off. Once you've completed your testing, in your test results magnifying glass, you will see all the tests that you've recorded so far today. We want to save this RV threshold, so select that one and then save it. We'll either transfer to a USB if there's one plugged into the programmer, or the programmer hard drive. It also saves it onto the device that you've interrogated. If we now go back to the device, into our patient information, implant data, you'll see our PSA RV measurements at the bottom here. Just press program in order to save it onto the device. After we've saved our PSA measurements into the device, we can go back into the PSA application. Our implanter has now attached other leads to the PSA so we can update our display. You can choose either the surface trace, the EGM from the device, or the PSA signal. We select our other leads on here and you can see that we now have a P wave and an R wave displayed with every sense beat. Having both the RV lead and LV lead connected at the same time displays an RV to LV interval using the selected LV electrode. So you can see it's currently LV1. If we change this to another electrode and then exit, you can see the value has changed. This helps you decide which is the best electrode to pace from. For now, let's go back to 1 to 2. We can look at our injury current, and as we're checking A, we select it here and see the injury current updated beat to beat. Going back to the lead trace display, we perform our A lead checks in here, increasing our pacing rate and coming on to pacing. It gives us our impedance beat to beat, and we're currently set at 5 volts at 0.5 milliseconds. So we just decrement down. You can see that we're now missing and the current voltage is displayed on the screen, so we'll come up, so we've got a stable threshold, in this case 0.8, and then we can save that as our threshold, which you now see over here. Press and hold for 10 volts. There's no twitching seen, so we can wean our patient back down and just wait for some sensing to come back through. And you can see that it's changed from pacing output to a sense value, so we can turn off pacing. Another helpful feature on the programmer is the real-time EGM. It automatically stores threshold tests, and you can manually start recording by pressing the video camera icon at the top. If we go into our atrial threshold test, we get our EGM. We can see we had lost capture at 0.7, but at 0.8 we were capturing. You can annotate these, so a line to show our loss of capture, and a circle to show our paced P wave. We can then print these out. We have the option of a USB printer or a Bluetooth printer. I've got the SICD printer attached via Bluetooth, so here I can print this out. So here is the printout for the EGM with our annotations on. So let's close this now. So now we can test our LV lead. Currently set bipolar 1 to 2, and as we've connected multiple sets of PSA cables, we can test all of the available vectors without the need to actually move any crocodile clips around. At the moment they're connected to all 4 LV electrodes, the RV electrodes, and one of the RA electrodes is on the patient for unipolar vectors. Into the magnifying glass, increase the pacing rate and turn pacing on. We can see our change in morphology, so we're pacing at 5 volts, and we can gradually decrement down and see what the threshold is. So we're missing at 2, coming back up to 3, and then down in 0.1 volt increments. There we go, missing at 2.6, so back up. 2.7, we have consistent capture, so we can save that as our threshold. It's important to check for any twitching, so we press and hold for 10 volts at 2 milliseconds. We do have twitching in this case, so then we can be a bit more accurate. So on at 10, still twitching. Decrement down half a volt at a time, still twitching. And so on. So now we have no twitching at 5.5, so back up to 6, and we can save that as our threshold by pressing here. So let's wean off and then stop our pacing. So using this vector, our impedance is okay, our threshold is a bit high and we've had twitching at relatively low output. So let's try some different options. As you can see, the RV to LV interval is displayed. At the moment we're using electrode 1 and it's around 90 milliseconds. So let's go through some of the others. Electrode 2, around about 110 milliseconds. Electrode 3, that's close to 120. Electrode 4, and that's better, 135 milliseconds. So let's begin by testing electrode 4. Good separation seen there. So again, let's put our pacing rate up and turn pacing on. And then we'll gradually decrement down from 5 volts. Let's find our threshold. Okay, so we're missing at 1, and then come down from 2 and 0.1s. Actually, our threshold is 2, so that's saved now. And that was for 4 to coil. So what other options do we have for the 4th electrode? Let's try 4 to 2. So we're currently pacing at 5, so we'll come down from here. This is looking good. Oh, much better. So come down from 1. Okay, so a threshold of 0.7 at 0.5, and that's using 4 to 2. So we've got a good impedance and no twitching at 10. Now that we've tested all 3 of our leads, we can go into our test results and print out a report with all of these values on. So press print, and in this case we've still got the SICD printer connected, so it easily prints straight to there. And here you can see our report showing all of the LV vectors that we've checked, along with our atrial and RV measurements as well. Now we've completed all of the PSA testing and the leads have been attached to the device, so we can go back to the device application, into our test tab, run through our tests, so sensing impedance, and let's have a look at a threshold. So as always, pressing play, and then it will automatically decrement down from here. And we're looking to see where our loss of capture occurs, and ready to press end test whenever we see it. All looks good so far. There we go. So if you didn't quite see that, we now have this button here which will take you straight to the automatically recorded snapshot. We can scroll across and see what our threshold was. And there we go. So threshold of 0.8. And then you can come back into your test screen and edit the result if necessary. Now we've completed all of our testing. We've programmed everything we want. So let's just turn the device on, and then we can print out our final reports. Into the data tab, and on the left hand side we have all of our reports. So quick notes will give us our measurements from today, obviously PSA, we want that, and then our device settings. In the center column we have episodes, so if there's anything interesting from your follow-up, or our real-time log. So you can select anything that you want to print here as well. Print into either USB printer, Bluetooth printer. We've got the Bluetooth printer connected, or we could save to the hard drive. If you've got a USB plugged in, we can save to that instead. And data transfer is just if you want to connect to your hospital PC. So for the moment, we'll save it to the hard drive. That's all done. So now we can just end session. And there we go.